Hello, this is Jack Jackson. In this video, we're going to talk a little bit more about the binomial distribution and taking a look and see what happens to the graph of the PDF when we change the parameters just a little bit, change the n and the p. So in this graph, I have, I guess, 9 different binomial distributions. So the binomial distribution is a family of distributions. It's not just one single distribution. And for every different combination you have of n and p, that gives you a different distribution. So in all of these, n is 20. So there are actually 21 bars. There's a bar with x is 0, x is 1, 2, 3, all the way up to x is 20. Now some of these bars are so short we can't see them here, but they're not completely non-zero. They're just close to 0, so close we, for practical purposes they might be 0, but not for actual, theoretically. If we zoomed in enough, we could see some bars there. But on this scale we can't. And I use Minitab to generate several of these graphs all at once. But I'm varying p from different values. Actually, I have 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, and 0.9. And you can kind of see what happens there. So see what happens. Well, first of all, remember that the mean is NP. N is 20, is fixed, so the mean is 20 times P. So the bigger P is, the bigger the mean is. So if you notice when P is 0.1, the mean is over here at 2. This is right. Let's see, I think this one is 0. So 0, 1, 2. So the mean is right here. Okay. The next one, 0.2 times 20 is 4. So the mean is moved over to 0, 1, 2, 3, 4. There's the mean right there. That makes sense looking at it. That ought to be about the mean. It's also the mode in this case. Then we take n is 0.3. 0.3 times 20 is 6. So I think it's this one right here. I think the 0 bar is so short you can't see it. And these bars out here are hard to see. Okay, and so forth. And so the mean is moving to the right as this gets bigger. You can see the center of this thing is shifting right as we go along. Now, if it's perfectly symmetric if p is 0.5. So where's the one with 0.5? That's this one right here. That's perfectly symmetric, so 0 skewness there. But if the p is less than a half, it's skewed to the right. So the data is more concentrated on the left with a longer tail. Remember, this goes all the way out to 20 on the tail, even though it's real short. So we have a real long tail to the right. Data is concentrated to the left. So that one's skewed the most. So this is the biggest positive skewness here. Skewed a lot, but not as much as this one. A little less here, a little less here. Not skewed at all here. Now this one's skewed the other way, so as soon as you get the p bigger than a half, you're more likely to get a higher number of successes, higher than higher than what you would get right here, which is what? Actually half of them, which is 10. Half of the 20 is 10. So the mean here is 10 on this one, and the mean's going to be skewed a little bit for these others. Okay, so the mean is moving up here. Okay, but we have this longer tail to the left, so these are negatively skewed, and the most negatively skewed is this last one. So that's what happens if you vary p but leave n fixed. Well, what if we go the other way around? Let's say we pick p as something, let's just pick 0.4. It's not quite perfectly symmetric, but not far off of it. And then we're going to vary the n. Now remember that the mean is still NP, but this time the P is fixed, and the N is changing. So this is 0.4 N. So NP is 0.4 N. The bigger N gets, the bigger the mean. So again, lower N, we're over on this side. Bigger N, it's moving out to the right for the center. But also what happens is increasing N increases the number of bars. So here there are only bars from 0 to 5. 0, 1, 2, 3, 4, 5. So there's 6 bars there. Here we have 11 bars, 16 here, 21 here, 26 here, 31 here. The number of bars is increasing. And since all the heights add up to 1, if you got fewer bars, you're probably going to have some a little taller. So the height of the tallest part is sort of getting smaller. But we go out that way. And it's interesting the way the shape of this. There's a shape here. It's kind of mounded up. Kind of trails off on both sides. But the bigger n gets, the more it starts to look kind of like what's called a bell-shaped curve. It looks a little bit more like a normal curve. We'll talk about that a little bit later. Now, I actually have a couple of demonstrations here I want to show you. We kind of see this dynamically. First of all, if you're going to do these yourself, you may need to install the free Wolfram CDF player, which you can get at this link, and then you may be able to do these. Maybe you can do them without it, I don't know. But here is look here at this part right here. We have a binomial distribution. Right now n is 10 and the probability p is 0.5. And you can see what happens. I can go all the way down to n is 1, so it'd be 2 equal bars. So just a Bernoulli distribution then. And then if I go to 2, that gives us 3 bars, and so forth. And every time I move to the right one, it picks up more bars. It's also moving the mean to the right. The little red dot there in the middle is the mean. And you can see what changing n does to you. Kind of see it dynamically, which is useful. Now, what if I, maybe put it back to about 10 or so, and then look at the probability. Well, probability 0 means they're all going to be a success. Probability 1 is, well, it's probably 1, everything's a success. Probability 0, nothing is. Okay, so that's all at the 0 bar. That's all at the n bar. But if I get off a little bit, let's say, so as I come here, this gives me quite a bit skewed to the right. Now, what's happening to the skewing? A little bit less. Somewhere in here where it gets 0.5, it's perfectly symmetric. And now we're starting to hump up on the right side and tail off to the left. So that is changing the skewness. Isn't that cool? It's kind of neat how you can see that, see those things moving dynamically. This other link here is also to another one from the same demonstrations thing. And this actually has a whole bunch of different distributions. We're going to talk about the binomial. Later we'll talk briefly about the Poisson. We've mentioned Bernoulli and geometric and discrete uniform. And later we'll talk about hypergeometric. We probably will not talk about some of these other kinds. But let's say, for example, if we look at binomial, here is the PDF here. Here's the CDF. See the step function there? Okay, so in this one I can run n down and then run it up here. And you can see its effect on the PDF and the CDF. And then I can change the P here as well. I can do the same thing for a geometric. We looked at geometric earlier. And geometric just has the one parameter P, which changes how tall, I guess it's how tall the first bar is, but also then what's multiplied by it as it keeps going. Or Bernoulli's just got 2 bars, and you just change the probability of success. The heights of the 2 bars add up to 1. Okay, a discrete uniform there. This one you tell it the minimum value and the maximum value, and it's divided up into pieces for you there. Okay, so there's a couple of examples there. Okay, so now it's time for you to do a little more practice with some calculations. So here you can see a little bit about some things here. So here this first group, n is 10 and p is 0.5, and some various different calculations. X equals 4, x less than or equal to 4, x less than 4, x greater than 4, and x greater than or equal to 4. So you get to try to do some of these with all these different versions of the equation and inequality. And down here we're jumping around a little bit more. This one n is 15, here's p, and that's an equal to 7, and so forth. So there's 9 exercises. If you would, please go ahead and work these out now. Come back when you have your answers. Press pause now. Okay, here they are. I'm actually just going to just let you pause on this slide and check over your answers here. Make sure everything's correct. And this is how it's done on a TI-84. And I'll pause on the next slide and you can see how it works on the Inspire. Okay, so here it is on the TI Inspire. So if you have a TI Inspire, I invite you to pause and look over how the syntax is done here, and of course make sure that you can get these. So either way, make sure you can get these on your calculator, whichever calculator you have.